Welcome back to section 3 of chapter 10.1. I want to illustrate some of the homework that you'll be running into. The first thing is you may see a right triangle and they're asking you to find the missing side, find x. Well, I notice right here that that's a multiple of 4 and multiple of 5, so I'm wondering if this isn't a 3, 4, 5 right triangle. So my guess would be this would be 9 for the side. Now you can actually do this with 9 squared plus 12 squared equals 15 squared, and realize that it has to be 9 squared. So how did I get 9 so quickly? That's a multiple of 3, and this indeed was a 3, 4, 5 right triangle. So these ratios will ease the length of time that it takes you to do a homework assignment. Now over here, I'm given this example and said, find all 6 ratios. Now what they mean is sine, cosine, tangent, and then cosecant, secant, and cotangent. Well, in order to find that, I need to find this missing side. Well, I know that I have the intermediate side and the short side, so if I do the Pythagorean theorem here, I will find this. That's 16 plus 1 is 17. And if I square root this side and square root that, then I have the c value, which is here. C equals square root of 17, or in other words, that's the value of the hypotenuse. So let's start writing out then. And since this is theta, I want to start with the sine of theta, and this would be the opposite side over the hypotenuse, so I have 1 over square root of 17. Now earlier in the year I taught you to rationalize the denominator when there was a radical down here, so I'm going to put square root of 17 here and square root of 17 here. These multiplied together gives you 17. And so it turns out that our final answer is going to be square root of 17 over 17 for the sine of theta. So what if I want to write the cosine of theta? Well, what's that going to be? That's this 4 over the square root of 17, in other words, the adjacent side to the angle divided by the hypotenuse. So I'm going to write 4 divided by square root of 17. Then I'm going to rationalize it like this. Remember, what I'm multiplying by here is the equivalent of 1. It's just in this form, so that down here, multiplying these two together, I get 17. So I end up with my final answer looking like this, and that's the cosine of theta. Now let's take the tangent of theta. What's that going to be? Well, it's not going to involve my radical at all. It's going to be the opposite over the adjacent, so I get 1 over 4. Now you notice when I went through this, I didn't write out the words opposite over hypotenuse. I'm expecting you already to know those. So when I come to tangent of theta, you know this is the opposite side over the adjacent side. Okay, let's go over here and we'll do cosecant of theta. Now, if you recall, I told you that was the reciprocal value of sine. And sine was 1 over square root of 17 initially. So here, I'm going to write it like this. taking its reciprocal. However, I don't need to write the 1 at all, so I'll just write square root of 17 is the cosecant. So let's take a look now at the secant of theta. Well, that's the reciprocal of our cosine, and that was 4 over square root of 17 before I rationalized it. So I'm going to do this, write the hypotenuse value on top over 4, and I'm done. Just leave it. And then cotangent, we'll write that one next. And I'm going to write 4 over 1 just for your sake, because that's the adjacent side over the opposite side. But you know we don't need to write that, so your answer here with the cotangent is just 4. So I've written all 6 of them. You discover, first of all though, it takes you a little time to find the first 3. Once you find those 3, it's easy to get at the remaining 3, because you just turn over the answer that you found here. Now, I want to sign, I guess I'll tell you all this. Now, take the first letters as an acronym. So, cosine now is adjacent over hypotenuse. And of course, taking those first letters to make the acronym, we would have C, A, H. So you have so, ca. Now if you look at tangent, you'll see opposite over adjacent. And the acronym for that is T, whoops, I'll make it capital, T-O-A. Okay, get ready. This sounds funny, but it'll help you remember them. SOHCAHTOA. And that has the correct order of the pieces. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And TOA is tangent is opposite over adjacent. So that might help you memorize the first 3. The other 3 people have come up with similar acronyms for them. I don't bother with that, because once I know these, the reciprocals are all over there. So if I just keep that straight, I just need to keep these in mind. So it's a little trick to help you memorize and keep them in the right order. Now, the assignment that you're working on, I'm going to ask you to let me know through the my LLA whether you have questions about particular problems. So just send me a short email, and if I get more than one question about that, I'll actually show you how to do that here. If it's just one of you, I will sketch that out and email you back so you understand. So if you have questions, communicate with me on my LLA, and we'll get at the answers here so you can finish up the homework. So I'm happy to help in any way. If you pay attention to the bulletin board, I'll be giving you information there about our continuing and ongoing assignments, and then I will invite you to be part of a discussion that basically is a check-in time for me to see that all of you are out there looking at these things and progressing in your homework. So watch the bulletin board for the discussion time and a way in which you can actually check in with me and ask me questions directly right then. Okay, thank you.